Stop before you scroll past this video. I need you to actually think about what you're looking at. This is Greenland. It is the size of Western Europe. It holds enough ice to raise global sea levels by 7 meters if it melts. You've probably seen it on a map your whole life. A white mass at the top of the globe that most people never think twice about. But in the last 3 years, scientists have found something underneath it. Not one thing, not two things. A collection of discoveries so strange, so structurally bizarre, so deeply inconsistent with what we thought we understood about ice, geology, and planetary history, that the foundational models we use to predict sea level rise, the ones feeding into every climate report on Earth, are being quietly rewritten. And almost nobody is talking about what it means. Today, we're going under the ice. To understand why these discoveries are so disorienting, you need to understand what scientists thought they already knew. For decades, our picture of what lay beneath the Greenland ice was boring. Bedrock, ancient rock, cold, stable, frozen, inert. The ice sheet sits on top of it, like a lid on a jar, compressing it under millions of tons of pressure, sealing it from the atmosphere, sealing it from the sun, sealing it, we assumed, from anything interesting happening at all. We've been drilling ice cores in Greenland since the 1960s. We have reconstructed climate records going back 800,000 years from the bubbles of ancient atmosphere trapped inside. We know what the temperature was during the Eocene. We know when the last ice age ended. We thought we knew Greenland. Then in 2015, our researchers at the Alfred Wegener Institute in Germany were analyzing radar data collected by NASA's Operation Icebridge, a mission that had spent years flying aircraft over Greenland with instruments designed to peer through the ice. And they saw something in the data that didn't make sense. A circular depression in the bedrock, not a small one, 36 kilometers across, perfectly, almost impossibly circular. The depression was buried under nearly 2 kilometers of ice. So they thought it might be a glacially carved lake basin. They checked, it wasn't. They thought it might be a volcanic caldera. They checked, it wasn't. What they eventually concluded, after 3 years of analysis, published in a peer-reviewed journal, was that this structure was a meteorite impact crater, one of the largest on Earth, and it had been sitting under the Greenland ice sheet, undiscovered, for, at minimum, 2.6 million years. That would have been interesting enough. But then they found a second one. In 2019, the same research team announced the discovery of a second large impact structure beneath the Greenland ice. This one, 36.5 kilometers wide, located 183 kilometers from the first. 2 craters, the same general region, both ancient, both perfectly preserved under ice, that no geologist had properly penetrated. The chances of 2 impact craters of this scale appearing so close together are, statistically, almost zero, unless they're related. The working hypothesis now is that these are a doublet impact, 2 objects from the same parent body arriving at roughly the same time, which raises a question that nobody in the press seemed to ask. If an asteroid impact of this magnitude struck northwest Greenland, what did it do to the ecosystem? What did it do to the climate? And why is the bedrock beneath the impact so geometrically perfect? Because here's the thing about craters from space. They're not usually circles. Most impact structures are elliptical because objects almost never hit at a perfect 90-degree angle. A perfectly circular crater implies a near vertical impact at extremely high velocity. An impact that leaves a perfect circle in the bedrock of Greenland came straight down. At what speed? From what direction? At what angle? Nobody knows. Now, before we talk about what was found inside the ice itself, I want to be precise about something. These discoveries are not fringe science. They are not from conspiracy YouTube channels or anonymous blogs. They are coming from the Alfred Wegener Institute, Harvard University, the University of Copenhagen, NASA. They are being published in Nature, Science, Geophysical Research letters. This is the scientific establishment finding things it does not fully understand yet. And in February 2026, the most physics-breaking discovery so far was published. So, researchers studying the interior dynamics of the Greenland ice sheet discovered that the ice deep inside was churning, not flowing, not sliding, not compressing, churning. The technical term is internal convection. It's the same process that makes a pot of pasta water circulate when you heat it from below. Hotter, less dense material rises, cooler, denser material sinks, a circular current forms. That process is well understood in fluids. It has never, in the history of glaciology, been observed in solid ice. Ice doesn't do that. or it wasn't supposed to. The reason this matters is not just scientific curiosity. Every sea level model on Earth runs on equations that describe how glacial ice behaves, how fast it flows, how it deforms, how it responds to temperature. Those equations assume ice moves in predictable, well-characterized ways. So, if ice can convect, if it can churn internally like a heated fluid, then those equations are wrong. Not a little wrong, structurally wrong. Every time you've seen a graph projecting sea level rise by 2100, the numbers on that graph came from models built on physics that didn't account for this. The researchers were careful, as scientists always are, to say their findings are preliminary. More study is needed. The rate of convection is slow. The implications are uncertain. But privately, and this is documented in the commentary accompanying the paper, several co-authors noted that if this process is occurring at scale across the ice sheet, current projections could be significantly underestimating the pace of ice loss, not overestimating. And then there's the subglacial lake. In 2025, in a region of northwest Greenland that was predicted by every existing model to be permanently frozen at the base, a subglacial lake erupted, not drained. Not slowly receded. Erupted. The pressure from the water below drove it upward through 2 kilometers of ice and, in what scientists described as a hydraulic fracturing event, blasted a visible crater through the surface. The region where this happened was not supposed to have liquid water at the base. The model said the ice there was frozen solid to the bedrock. The geothermal heat flux wasn't high enough. The pressure wasn't enough. The temperature wasn't enough. The lake didn't care about the models. I want to step back from the physics for a moment, because I think the most staggering discovery isn't even the craters or the churning ice or the lake that shouldn't exist. I think it's this. Under the same ice sheet, in material recovered from deep drilling operations, scientists found a 2.7 million year old ecosystem. Not fossils, not mineralized impressions, actual organic material, preserved, leaf fragments, mosses, insect parts. In nearly perfect condition, preserved by the ice itself, from a time when Greenland was a forest. 2.7 million years ago, before Homo sapiens existed, before Neanderthals existed, before most of our genus had evolved, there was a forest in Greenland. Trees, insects, a functioning biome. And then the ice came, and it froze everything in place, perfectly, cryogenically, and buried it under 2 kilometers of ice, where it sat undisturbed until a drill bit hit it in the 21st century. The scientific team, led by researchers at the University of Vermont and published in Science in 2023, found that the DNA in this material was not just present, it was sequenceable. They reconstructed a partial genetic profile of the ancient Greenland ecosystem. They found evidence of ancient relatives of plants that still exist today, species that have been evolving for millions of years from ancestors that were alive when Greenland was green. That's it. And here's the part that has not received enough attention. That forest didn't die slowly. It didn't gradually freeze over thousands of years while the ecosystem adapted and migrated south. The preservation is too perfect for that. The ice came fast enough to cryogenically preserve leaf matter, insect parts, and viable DNA across 2.7 million years. And this connects to the final discovery I want to tell you about, one that should, I think, reframe everything else. In 2021, our researchers published evidence that the entire Greenland ice sheet, not the edges, not a portion of it, the entire thing was ice-free as recently as 400,000 years ago. Not the Arctic, not the fringe, all of it. And then, even more recently, analysis of material from Camp Century, a Cold War-era military base drilled into the northwestern ice sheet, revealed evidence that a large section of the Greenland dome completely melted as recently as 7,000 years ago. 7,000 years ago, modern humans were building the first cities. We were developing agriculture. We were painting on cave walls in what is now southern Europe. And the northwestern dome of Greenland was gone. The temperature required to melt that dome, the researchers calculated, was not dramatically different from temperatures we are approaching today. Not temperatures from a deep geological past. Not temperatures from before the dinosaurs, temperatures from the climate trajectory we are currently on. And when the dome melted, the sea level rise associated with that event was, according to modeling, significant enough to inundate coastlines globally, not in 10,000 years, in the span of a human civilization. So here's what I cannot stop thinking about. The scientific community, the peer-reviewed, grant-funded, institution-affiliated scientific community, has in the span of about 8 years discovered 2 previously unknown giant impact craters beneath the ice, geometrically perfect. From an impact we still don't fully understand. An entire ancient ecosystem, cryogenically preserved from a time before our species existed. Evidence that the ice sheet has already fully melted and reformed at least once in relatively recent geological history. At temperatures we are approaching, physical behavior inside the ice, convection, that the laws governing our sea level models said couldn't happen. And a subglacial lake that exploded upward through 2 kilometers of ice in a region where liquid water wasn't supposed to exist. Each of these discoveries was published. Each was peer-reviewed. Each generated a news cycle of approximately 48 hours. A handful of articles in science publications, maybe a brief mention on a major outlet, and then disappeared back into the noise. I'm not suggesting a conspiracy. Scientists are not suppressing these findings. They're publishing them. They're presenting them at conferences. They're applying for follow-up grants. What I'm suggesting is something more uncomfortable than a conspiracy, that these discoveries are individually legible and collectively incomprehensible, and that the gap between those two things is where the real story lives. Any single one of these findings in isolation is a fascinating science story. All 5 of them together, over 8 years, from the same ice sheet, pointing in the same general direction, that's a different kind of story, and we don't have a framework yet for telling it. Here is what I believe we're watching in real time. The planet's largest refrigerator. The structure that has been stabilizing Earth's climate, sea levels, and oceanic circulation for millions of years is revealing as it slowly opens that we understood it far less than we thought. And the things we're finding inside it, the craters, the frozen forests, the impossible physics, the ancient lakes, are not separate curiosities. They are chapters of a longer story. A story about what this place was, what it did, what it became, and possibly what it's becoming again. 2 kilometers of ice, a 36-kilometer circle carved in bedrock, a frozen forest that was alive before we existed, and ice that shouldn't move, moving. The ice is talking. We're just learning how to listen. If this video made you feel something, curious, unsettled, that itch you get when a story is bigger than it first appears, subscribe. This channel exists for exactly that feeling. And I genuinely want to know which of these discoveries hit you hardest. The craters, the frozen ancient forest, the physics that shouldn't be possible? Drop it in the comments. I read every single one, and the top comment gets featured in the follow-up video, which is already in production. The ice has been keeping secrets for 3 million years. We've got time to learn them properly.